Good afternoon, ladies and gentlemen. All right, so today we're looking at writing the equation of a parabola. Okay. So before I get started and show you how to do that, I just kind of want to go over some quick things real fast. One, the parts comparison to the actual equation you're going to be writing. Okay. And I'm going to kind of just go over. This is the focus point right there. Okay. This is the directrix line. Okay. The vertex point is right here. I didn't actually mark it, but that's the vertex point. And then the distance from here to here and here is still the P. So that's not going to change. So whenever we write an equation, we essentially have to have three parts. We have to have the A value, the H, and the K. Those three parts. The vertex itself is the HK part of the problem. Okay. The A, we're going to essentially get from the P. So if the graph is opening up, that means that we have a vertical y equals, and the A value is going to be positive. If we have a vertical opening down, again, if this is your focus, this is your directrix and your vertex point, that means that your equation is still vertical, but now your A has to be negative instead. Okay. If you have a parabola that opens to the right, you're still going to need the pieces that you have. You still need the A, the K, and the H. But again, notice one thing, the H and the K are written in a different position. Okay. So you have to be very careful when you do that, as your vertex is written in the HK form. Okay. But you need to have the A, the H, and K. Again, focus, directrix. If it's opening to the right, your A is positive. And again, if the graph is opening to the left, your focus, directrix, and vertex point, then your A is going to be negative. Okay, so keep that in mind. And the last thing is to find our A value. We're going to use this formula 1 over 4P again. So hopefully you know how to use it at this point. If not, obviously we'll go over it again. All right, so here's what it is, and here's the way it works. We don't know the equation, but what we do know is information that's going to be given. So we know that the vertex is sitting at negative 3, 0. The directrix is at negative 1.5. Okay, so here's what happens. I'll plot the vertex at negative 3, 0. Here, your directrix line is at negative 1.5 x equals. So negative 1.5, and I forgot my ruler this time. So I'm going to pause this and go get my ruler real fast. All right, I got a ruler. I didn't get actually my ruler this time, but I got a ruler. So I'm going to kind of just do this. So your directrix is about right there. Okay, so here's what you know. Since the vertex is here and the directrix is here, the distance from here to here is 1.5. Okay, 1.5. That means that your P value is going to be not 1.15, 1.5. Okay, and we're going to use this to find our A value. So if A is equal to 1 over 4 times P, and it's going to be 1 over 4 times 1.5. So again, I'm going to do my trusty little calculator real fast. 1 over 4 times 1.5, kind of like that. Oh, I get a decimal fraction that's making it to a fraction. So math fraction gives me 1 over 6. So my A value is going to be 1 over 6. Now here's kind of the thing. Because your directrix is sitting right here and your vertex is right here, that means the graph's going to actually open this direction. Since it's going to open to the left, okay, it tells me two things. One, it tells me that my A value has to be negative. But two, it also tells me that my equation has to be x equals. Okay? Since it's x equals, well, A we know is negative 1 over 6. And then this is going to be y squared plus h. So this will be k, this will be h. Well, k, I'm going to come back to my vertex point, was at negative 3, 0. This is h and k here. Since k is 0, then you can put 0. You don't have to. You could just leave it as, you could just leave it as y squared plus k, and in this case would be plus a negative 3. So then my equation itself, I'm going to rewrite it down here right below it, is going to be negative 1 over 6 y squared minus 3. Okay, and that's how it's going to work. So this is what you're looking for right here. Okay, so I'm going to go to the next one. Again, at this point, if you think you have a good understanding, I would pause it and try it before I do it to make sure you get it. If not, keep watching. So the vertex is at 2, 4. That's my HK. Focus is at 2 and 1.5. Okay. So my vertex is at 2, 4. 1, 2, 3, 4, right there. My focus is at 2, 1, 2, and 1.5. So about right there. That means the distance from here to here is 2.5. Okay. This is at 4, 1.5, so 2.5. So my p-value is 2.5. That also tells me my graph's going to open downwards, kind of like this. We don't know where, but somewhere. At this point, it doesn't really matter because we're just writing the equation anyway. So again, I know my a value is going to be negative. I also know it's going to open down. Since it opens down, it's going to be a y equals equation. Okay, so y equals, let's see. A is equal to 1 over 4 times 2.5. Okay. Go back to my calculator real fast. 4 times 2.5, kind of like that. And we get 0.1. I could use 0.1 if I really wanted to. I'm going to go ahead and just do the math fraction to get my fraction of 1/10. So I know this is going to be a negative 1/10. So y equals to a negative 1 over 10. Again, hk. So that's going to give me x minus 2 squared plus 4. Okay, moving on. Again, if you think you got it, try it, and then see what happens. We'll go from there. Focus is at 1, 4. And I'm going to label this F this time, and there's a reason for that. Directrix is at x equals negative 5. 1, 2, 3, 4, negative 5. But it's going to come down like this, kind of like this. So here's the thing. We don't know the vertex point, which we need in order to find the HK. So I'm going to put vertex down here real fast and figure out what that's at. Well, if you remember the distance from P is going to be equal on both sides, that means that halfway between your focus and directrix is your vertex point. Well, 1, 2, 3, 4, 5, 6. So if I go 1, 2, 3, about right there, 1, 2, 3, right there, that's my vertex, which looks like it's going to sit at negative 2, 4. That also tells me my graph opens to the right like this. Since it opens to the right, my A is going to be positive. The P itself is 3 because we just found that. Okay. So then if I do 1 over 4 times 3, that's going to give me 1/12. So my A value is 1/12. We know it opens to the right. My vertex in this case, I figured out, was at negative 2, 4, which is my HK. So again, because it's a horizontal, this is actually going to be x equals my A, which is 1 over 12, y minus 4 squared minus 2. Remember, the inside here, you're going to use the opposite. So if it has a positive 4, that'll be a negative 4. It doesn't matter if it's h or k. If it's in the parentheses, you're going to use the different number. So positive 4 here gives me the minus 4 here. Again, I can go into y later on if I need to, but I'm not going to right now. Okay. Last one. Again, plot the point, -4 and about 1.5, about right there. My direction is at y equals -3.5. 1, 2, 3.5 is about right there. So I'm going to graph that real quick, my line. Ew. Wish I had my other ruler. It works much better than the straight one. Anyway, right there. So y equals -3.5 right here. Here's the focus. My direction is somewhere in between. So if I go 1, 2, 3, 4, 5, so halfway, it looks like it's going to be 2.5 maybe. So 1, 2.5 is about right there. So 1, 2.5, 1, 2.5. So there's my vertex point right there. That tells me that my P is 2.5. My vertex is sitting right there at -4, -1. That also tells my graph opens up like this. So my p-value is about 2.5. My a value, 1/4 times 2.5. Well, we did that one earlier, didn't we? And we got 1/10 when we did it. And again, since it's positive, opens up. Vertex I said was at -4, -1, which is your HK. And then my equation, since it's vertically up, that's going to be a y equals my a value, which is positive. And then x minus h would become a +4, since it's already negative, squared, and then -1. Okay. All right. Look at some word problems. So don't be frightened by these because it'll give you the information that you need. What you do know is this, that this point right here is your focus point. This is your vertex point right here. Okay. And I don't really need my directions to do this. I also know because this is opening up, it's going to be y equals an a x minus h squared plus k. Now, if I read through this, okay, it doesn't tell me anything about the vertex. Since it doesn't tell me anything about the vertex, I'm going to basically put my vertex at 0, 0, because I have that option to do so. And it makes this a little bit easier to do. Okay. So now I can do my A, because this is my focus point right here. So A, sorry, you can't see that, is going to be equal to 1/4 times 10. So A is equal to 1/40. So I can actually write my equation really quick now because of this. Y equals to 1/40. X, since there is no 0, squared, and then there is no deal, so my equation is actually that. So here's the question. How deep is the dish? Well, here's the thing. I'm going to try and figure out this point right here to right here. No, it is not 10, so let's just be careful with that, okay? But here's what I do know. This point right here, since this is 37 all the way across, this point right here, from here to here, and from here to here, 37 divided by 2 is going to be 18.5. So I know this much. I know this point is going to be 18.5 and some y value. I don't know what. But if I take my equation now and I say y is equal to 1/40 times 18.5 squared, I consider that the depth is 8.556, and this is this feet? Yeah, this is feet. Feet deep. Okay. Pretty straightforward problem. Okay. Another piece here. Some dimensions, 13 feet across like this. I'm going to read through it, just kind of see what it says. Distance in here, distance of 2.5 from the vertex. So I need to figure out, it looks like the p-value this time. So we had a problem like this actually on a prior assignment, a prior video. So since I don't know the vertex and doesn't tell me, I'm going to do this again. I'm going to put my vertex here at 0, 0. You don't have to always do this, but because it doesn't actually tell you anything about the vertex, I'm going to just use that. The other thing I know is this. I also know that I don't know P, but I do know this point right here. Because essentially, if I go down here, this coordinate happens to be at 2.5, comma, negative 6.5. Okay, kind of like that. And now if you don't understand why, because from here to here is 6.5, and since it's below 0, it's negative 6.5. And then this is 2.5 because it tells me that the depth here is 2.5. Okay. My equation, it's horizontal opening right. So it's going to be x equals to a, since I don't have one, y squared, kind of like that. Now a, since we're trying to figure out what p is, that's what we're really trying to do. I'm going to do this. I'm going to make this x equals 1 over 4p y squared instead. Okay. I have an x and a y this time to work with, so I'm going to use those to kind of do this. So 2.5 is equal to 1 over 4p times a negative 6.5 squared. And I'm just checking myself to make sure that I'm not going too fast on myself and then missing it. Okay. So 2.5 is equal to 1 over 4p times, it looks like 42.25. I'm going to divide both sides by 42.25, kind of like that. So 2.5 divided by 42.25. Turn that into a fraction real quick, and that's 10 over 169 is equal to 1 over 4p. And then I'm going to kind of do this a little differently. I'm going to multiply this side by 4p to get rid of it. I'm going to multiply this side by 169 to get rid of it. So then that gives me 40p is equal to 169 divided by 40. So that p is equal to, looks like 4.225. Okay. A little bit more math than you're probably wanting, I know, but it's, you get used to things like this and it makes a whole lot of other math problems a little bit simpler. Okay. But anyway, there you have it, folks. Run the equation, and in this case, evaluating and using the equation itself to figure some things out. So, all right, that's all I got for today. Peace out.